I'm good there, guys. Welcome back. This is for last question. 4.6. I apologize. I couldn't finish. Because of load shedding. South Africa, you know how it is. So okay, let's finish the last question. Say they determine whether the x-intercept of the straight line CD also lies on the altitude perpendicular, meaning the perpendicular height from A to BC. Okay, let's go back to our diagram. So guys, here they want to know where from the x-intercept of line CD is this here, this line here. Okay, x-intercept came. Okay, so remember from our equation, guys, right? We had that like y equals to 2x minus 2 for CD. Okay, it's for CD. So to recreate our x-intercept for CD, we need to say what? We need to let y be 0. Okay, so we can get our x-intercept. So mean returning 0 equals to 2x minus 2. We take this to the other side. About 2 equals to 2x. We divide by 2. We divide by 2. Our x guy 1. So our x-intercept guy here go 1 and what and 0. Guys, if you can see already, more necessarily answer is because of I was already tackling the question, and then load shedding happened. And then if you didn't watch the previous video, you can go and watch the previous video so you can understand what's happening here. Okay, so let's continue. So x again go 1, and then we intercept again more about 0 mo 1, and then mo 0. Okay, for line CD I can apply the x intercept, yeah, line CD, whether the x intercept of the straight line CD, okay, straight line CD, the x intercept that thing also lies on the perpendicular height from A to BC. Okay, so they want to know from A, right, to BC. So line BC get this one, the get B get C. So banya go itse gore line from here e tlo feta mo x intercepting ha e fitla mo e tlo ba like e tlo create 90 degrees na, like e tlo ba perpendicular to line BC. Okay, so the only way that, guys, we can get that gore e tlo ba perpendicular to BC na, only if re ka kry the gradient, right? Remember gore ne ke le boditse gore mo, guys, right, if mxy, the gradient of mxy ke times the gradient of mzm, something in minus 1 if it is perpendicular. Okay, so we can get the gradient for BC and also get the gradient for A. Okay, let's give this can see what, let's say here maybe z for line AZ. Okay, hore the gradient that this line had times the gradient that this line near for minus 1 and now. Okay, so okay, let's go. So the gradient for MBC irfang it'll YC minus YB over XC minus over XB. Okay, so YC regrang our YC regra minus 4, and then YB regra minus 1 over XC regra minus 1, and then XB regra minus 4. Okay, so roaring minus 1 minus 1 minus 4 minus 1 minus 5 minus 4 minus 1 minus 5, we get what? We get 1. So the gradient for BC, okay, get 1. Okay, so now let's check the gradient for AZ. Okay, the gradient for AZ, you got YZ minus YA over XZ minus XA. So regra hore king YZ are nagging. Okay, YZ are nagging 0 minus YA are nagging 5, and XZ are nagging 1 minus 4, right? So only minus 5, and then minus 1 minus 4 to for positive, so to for positive what? 5. So you get what? Minus 5 over 5 for minus 1. So the gradient of MAZ get minus 1. So banya go hitse gore gradient tse ithutse di these lines di perpendicular to each other. The only way if we get times that from -1, we're going to conclude our the perpendicular to each other. Okay, and the layer. Okay, so let's check again now. Gradient of MBC times the gradient of AZ. Let's check. So MBC again, gradient that thing get 1 times -1 get AZ. Then 1 times -1 get -1. Therefore, you can conclude by saying okay. Where they say whether the x-intercept of the straight line also lies on the altitude. Yes, the x-intercept of the straight line CD also lies on the altitude from A to BC. And then Resnarna, you have concluded. Okay, apologize guys for I can't upload the first video. It's because of load shedding. You know how it is. Thank you for watching.